Researchers boosted an AI agent's success rate by more than 22 points, and the extra computing it cost was less than 0.5% of training time.
Before we get to how, imagine a giant AI, one of the biggest ever built, trying to buy something on a website. Now imagine a tiny one, hundreds of times smaller, trained a different way. Which one shops better? Hold that guess. And remember the cup on the kitchen counter. It matters later.
An AI that clicks through 40 pages and never realizes it's seen the same one before. A map nobody thought to draw. And a training method that costs almost nothing. Every time you hear about AI agents booking your flights or managing your apps, this is the problem underneath. The agent clicks 40 times, gets 1 grade at the end, and has no idea which clicks mattered.
You'd think, Bella, if it tries the same task 8 times, it'd notice when it lands on the same page twice. Same checkout screen, same search results.
But the standard methods treat every attempt as its own straight line. 8 lines, no overlap, and no shared memory. In June 2026, a team from Peking University and Microsoft asked, "What if you drew a map instead?" Think of 8 people in the same airport. Watch them separately and you get 8 stories. Lay their paths onto one map and you see it. They all passed through the same checkpoint, the same hall, and the same gates. That's what the researchers did with their AI's attempts. Every time 2 runs hit the same screen, that became a shared point on the map. Of everyone who passed through a given point, how many went on to succeed?
So instead of judging a spot by one lucky or unlucky run, you average all of them.
Right, Eric. When you average across every attempt that hit the same spot, the lucky and unlucky runs cancel out. But the map unlocks something else. You can score each action by how much absolute progress it made, measured against every move on the entire map, not just the options right at that spot. Keep the cup in mind. That difference is where everything turns.
So if the map is doing its job, these agents should get a lot better.
On web shopping, the mapped version beat the previous best by more than 22 points. And it added less than 0.5% to total training time, just arithmetic on data the AI already collected.
And the guess? Giant AI versus the tiny one?
Eric, the giant scored 17%. The tiny trained model, using the map, hit 71%.
Tiny one won. Not even close. But what about that cup, Bella?
Now it makes sense. The task, cool a bowl and put it in the microwave. One action moved a cup to the microwave. Wrong object, dead end. Another action reached the fridge, where you'd actually cool the bowl. Old local scoring? The fridge move barely stood out. New global scoring lit it up as the real breakthrough. The map caught what the straight line missed.
Clean result. Though, this works best when the AI keeps landing on the same spots. On messier tasks, where situations rarely repeat, the gain shrank to just a few points. The map's only as good as the overlap.
Worth knowing. If a tiny trained AI already beats a giant one, should we be pouring money into bigger models or smarter training? Leave your take in the comments.
If you want more like this, subscribe. We break down a new paper every week.
Keep an eye out for the first agent that learns your daily workflow, and ask whether it trained on a map or a bunch of separate lines.